Hello and welcome to Mind the Stats. My name is Mohammed Udisi and I'm here to talk about risk assessment using binomial distribution. My mission is simple: to take a difficult subject and break it into small sections to make it less of a challenge. I'll walk you through one or more examples to reinforce what you've learned, and I welcome your feedback, questions, and suggestions. Please subscribe to my channel for future sessions or improvements, and thank you in advance. No one can predict events in the future with 100% certainty. There's always a risk for error. When sampling for defective units, we're only getting a defective rate for that specific sample. However, the sample may give us an idea about the entire population and make us wonder, can we use this information to find the rate for the entire population, or what would be our exposure risk? These are good questions, and binomial distribution allows us to make estimates with some degree of uncertainty. We often strive to get the worst case result. We refer to this as the upper bound. There are several tools to perform such tasks, but in this session we'll use the one proportion in Minitab. One proportion is a tool used to estimate a binomial population proportion. Compare that proportion to a target value or reference value. In this section we'll only use for estimation but not for the comparison. We'll go over comparisons when we get to the hypothesis testing. We'll calculate the exposure risk at a given confidence level. This is called the upper bound. We'll also look at the median confidence of 50% and compare that outcome to the 95% results. 50% confidence is sometimes referred to as the median level and is sometimes preferred. The reason is that the resulting estimates has the same chance of being under or over the true rate. Finally, we'll explore the effect of sample size and confidence level on our estimates. This is how we do it in Minitab. When you first start Minitab, you get a blank screen that looks like this, with a session window where your output is displayed and a worksheet to serve for input and output data. A list of commands up here, and the command we're going to use is stat, basic statistics, and we scroll down to one proportion, and here we're going to say we're going to deal with summarized data. Essentially, we're going to look at exposure risks for if we, let's say, check 10 parts and find 0 defects, 0, a sample size of 10, with 50% confidence. Let's say we change this to confidence level 50, and what we're asking here Minitab to calculate is the exposure risk given this information that we entered. We click OK, and this is the result we get. This is the upper bound, meaning that the result could go from 0 to 0.066 or 0.067, right? So here's a summary slide of what we just did. In Minitab, we went to stat, we selected basic stats, and we selected one proportion, and we entered number of events or rejects found 0, and number of trials 10. That's our sample size. We clicked on option and selected 50% confidence level, and we clicked OK, and this is what we got. Now what this means is that if you select a sample size of 10 and find 0 defects, at 50% confidence level, your reject rate is really between 0 and 0.066. This may seem to you very low, but if you multiply that by a million, let's say, that gives you the defect per million that are at risk. This is the type of work where you could use macro to perform repetitive tasks, but we're not going to talk Minitab macros here, maybe in future sessions. Instead, we're going to perform the same command over and over for each row and column combination in the table shown here to the left. What this table says is that find the one proportion value for events, or in this case they're called rejects, 0, 1, or 2 rejects for the various sample sizes. If you chose to pick 30, for example, and you found 0 defects, this is what one proportion will come up with. So you're going to do this individually for every one of these combinations, but later if you learn macros, you can do this easily with macros. This table here is also displayed in graphical form here as a chart. What it says is that if we checked a sample of 30 and found 0 defects, that's this row in this column, we found the 0.0228 at 50% confidence. So this is the potential defect rate. If you multiply that by 1,000,000, you end up with 22,800 defects per million opportunity. That's potential defects. Here we look at the effective sample size. You may have heard this in the past. When dealing with attribute data, the higher the sample size, the better. To illustrate this, I went ahead and calculated the risk for 2 confidence levels for various sample sizes and rejects and event rates. This is the table. This is for the 50% and this is for 95%. And here on this slide, we're going to compare the effective sample sizes. So for 30 versus 500, you can see that the one proportion results are a lot higher for a small sample size. So what it's saying is that if I sample 500, then my risk is roughly 1,385, compared that if I only sampled 30, my risk is a lot higher, 22,840 parts per million. We're going to look at the same data, but differently now. We look at the effect of confidence level, 50 versus 95. So these 3 columns here is for 50% confidence level. This is for 95% confidence level. So if you want to compare the effect of confidence level when you do this type of work, you set the same sample size, let's say for sample size of 30, and finding 0 defects. You have these 2 numbers to compare, and as you can see, if you want a higher confidence level, then your exposure risk is a lot higher. Of course, it's 95,034 defect per million compared to 22,840. And this is a representation, graph representation. So as you can see, as n goes higher, the risk is lower, and this is the 50%, and this is a 95% confidence level curve. This concludes our session on risk assessments. If you happen to learn a thing or two from this, then please like my video, and better yet, subscribe to my channel for future releases. Please let your classmates and colleagues know about it. Thank you, and I'll see you on my next session.